This week we continue with the design concepts of the Lockheed Company and Kelly Johnson. These designs set the company and the man so far apart from their contemporaries at that time that to this day, in one design alone, that gap has still not been breached. These planes were so secret, it's only with the benefit of time that we can now look back in awe of their achievements. Even then, we'll probably never know all they were capable of. In the early 1950s, the expansion of the Russian nuclear arsenal and the increasing paranoia in the US was leading to the period we term the Cold War. President Eisenhower was promoting an open skies policy, virtually declaring his intentions to overfly Russian interests. In spite of the Russians declining the inquiry, the US pushed ahead with the presidential policy, and the world was pushed into nuclear hysteria. The fuel for the Western paranoia was the lack of verifiable information available to the US regarding the Russian long-range missile program. At the time, there was no aeroplane in the world that could safely overfly Russia and supply reconnaissance information. Kelly Johnson, who by this time had become chief engineer at Lockheed, forwarded an unsolicited approach to the government proposing to build and supply 20 of just such an aircraft in only 8 months. Kelly had the previous track record in groundbreaking design with the twin-boomed P-38 Lightning, an outstanding success in the Pacific Theater during the end of the Second World War. And the record-shattering F-117A starfighter that was just completing its production rollout. This plane was the world's first Mach 2 combat aircraft, and in spite of its initial teething problems, its performance alone was so far in front of its contemporaries that it would continue its production for at least the next 30 years. The concept proposed by Lockheed was for an extremely high-altitude reconnaissance and surveillance aircraft. The extreme altitude would keep the plane beyond the range of interception aircraft, anti-aircraft weapons, and guided missiles. If the plane was out of range, then the need for high speeds would be diminished, and this allowed a huge increase in the unrefueled range of the aircraft. Kelly considered that some of the F-104A's concepts could be used in the production of this eye-in-the-sky. The starfighter was constructed for a specific purpose, with a very basic theme behind it. It would do without the things it did not absolutely need. This concept would carry through to the proposal. The starfighter's new minimalistic airframe would be an ideal base to start on the special strategic reconnaissance mission, after it was modified with huge glider-light wings and lightened by deleting such weighty items as landing gear and the ejection seat. The aircraft that was unveiled at the Groom Lake test site in December 1955 bore all of these characteristics, and the lineage from the F-104 couldn't be mistaken. Kelly Johnson made his incredible 8-month delivery deadline. It was christened the U-2 to maintain its secrecy, with the U standing for utility in an attempt to divert awareness from its espionage roles. For the pilot, the U-2 was an extremely demanding craft to fly. At the extreme altitudes in which it worked, the envelope between its stall speed and its entry to transonic flight was very narrow. In the U-2 at 70,000 feet, this difference was only about 12 knots. Below the 400-knot stall speed, the plane would fall back to denser air. Above 412 knots, because of its necessity of lightweight construction, the wings could shear off. Later improvements to the plane increased load, and higher thrust engines saw this envelope decrease to less than 5 miles per hour. Its mission was to photograph ground-based Soviet military installations. Originally, it was hoped that the plane could fly so high that the Russians couldn't even detect it. As it turned out, although the Russians could see the U-2 on radar, it flew so high that it was out of range of their missiles and aircraft. There was nothing they could do about it. Because the Russians couldn't shoot it down, the U-2 flew freely over all of Russia for 4 years, taking pictures of all the Russians' high-security military equipment. Finally, after 4 years of providing the US with the most valuable information during the entire Cold War, one was lost to Soviet action. Surprisingly, it was not actually shot down. The Russians sent up an interceptor. At the same time, the Soviets were also firing missiles at the U-2. None of them could hit the U-2 either, but one did hit the Russian MiG. The subsequent shockwave from the explosion broke off the U-2's fragile wings. This caused an international crisis, and the world held its collective breath. The loss also formally ended all U-2 missions over Russia. The U-2 evolved essentially as a powered glider, with a sailplane-like high aspect ratio wing and lightweight structure. A typical weight-saving device was the use of jettisonable wingtip wheels for takeoff stability. Landings were made on the main wheels and tail wheels, and the wingtips were turned down to serve as skids. In 1979, the U-2 was put back into production and rechristened the TR-1. Though TR-1 is somewhat larger, it's essentially the same aircraft as the original U-2. The once optical cameras have been replaced with newer thermal and electronic technologies, and a number of engine upgrades have been made. The TR-1 is still in use today in its original role of covert reconnaissance, but more specifically in areas of disaster relief and many other research areas, including with NASA for high-altitude research. The designers at Lockheed foresaw the likelihood of the Soviets developing weapons to clear their skies of U-2s even before they were put into service. At the stage that the Russians could reach the U-2 ceilings with their weapons, the only choice left then was to outrun them. Even the most advanced fighters of the time were flat out at Mach 2. Nothing came close to the requirements for these reconnaissance missions. To build a plane that would achieve a cruise speed beyond Mach 3 and altitude of 80,000 feet, totally new design concepts needed to be developed. It would also require totally new materials to be conceived. Along with this was the requirement of engineering new tools and machines to make the new aircraft parts. Everything about this concept would have to start from scratch. During 1957, the 12th proposal presented to the government met with approval, and so development began on Project Oxcart and the A-12. The planes of this series were later to be known as Blackbirds. Lockheed had in the past used titanium in some of its developments. However, this venture would require 93% of the plane to be a new titanium alloy to achieve the integrity required. Even to this day, the landing gear is one of the largest titanium blocks ever forged. At Mach 3, the outside skin of the plane would be between 800 and 1100 degrees Fahrenheit, while the outside air temperature would be below minus 120. The stresses on the airframe would be more than anything ever attempted before. Every aspect of this plane's development was new or exhaustively adapted. Even the basic fact that standard construction tools would corrode the titanium alloy had to be overcome. Because of their cadmium coating, which caused the corrosion, these tools had to be reforged to suit the production process. Totally new presses, mills and lathes had to be developed for use with the new alloy. Presses would now have to function at over 1500 degrees Fahrenheit. New non-corrosive cutting fluids would have to be developed. The list was never ending. What is probably most amazing in today's world is that all of this was achieved without any computers. It was all done with slide rules, pencils and pieces of paper. After the initial constructions, the static testing commenced. Here you can see hydraulic testing on the airframes, forcing the loading that would occur during Mach 3 flight. The corrugations in the skin were to make allowance for the expansion due to heat at beyond 2,000 miles an hour. Every individual piece of the plane was tested, even the wheels, tyres and brakes. With what this plane was expected to experience, nothing could be left to chance. Safe evacuation in an emergency was simplified. As the crew's flight suits were closer to spacesuits, no special enclosures were required in an emergency. Specially constructed ejection seats and parachutes were used in getting the crew clear of the plane at over 2,200 miles an hour. As the A-12 was in concept built as an interception fighter, the armament would have to be suitable for use at beyond Mach 3. However, if the plane is travelling faster than a bullet, guns wouldn't have been of much use. The weapon design was the Hughes AIM-47 missile and the Phoenix missile system. This was later used very successfully in the Grumman F-14 Tomcats. However, because of political decisions at the time, the A-12 was never actually developed as an interceptor. It would only proceed in its surveillance form. This caused some consternation within the design team at the time, and perhaps rightly so, as to this day there's still no long-range interceptor that even comes close to the Blackbird's performance. Lockheed would have to live without the acclaim that the Blackbird so richly deserved, and instead accept the mystique that has been associated with these aircraft ever since. The A-12 was first displayed to the public on September 30, 1964 as the YF-12A Interceptor. The airframe was in its simplest form, a blended body and delta wing built around two of the largest engines ever constructed for an aircraft. The Pratt & Whitney J58 engines produce 160,000 horsepower, and the inlet temperatures can reach an incredible 2,000 degrees Fahrenheit. The long, flattened fuselage, thin wings and specially designed paint achieved the first in genuine stealth technologies. In fact, the Blackbirds had less than 1% of the radar signature of a B-52. The engines placed midway out on the wings were continuous afterburning turbojets and left over 3,000 feet of turbulent air in their wake. These monster engines would consume in excess of 8,000 gallons an hour of their specially designed fuel. On high Mach missions, even with 5 onboard fuel tanks and special honeycomb storage inside the wings, the Blackbirds needed refueling every 45 minutes. On the ground, the Blackbirds actually seep fuel from their fuel cells, But once in flight, the expansion from high Mach temperatures soon seal all of these small leaks. Kelly-Johnson asserted that each flight above Mach 3 would in effect retemper the titanium alloy of the plane, in theory prolonging the airframe's life indefinitely. The main difference between the YF-12A and subsequent models was the shortening of the chines along the sides of the nose to allow for surveillance radar installations. To counter for the loss in stability, small ventral fins and a retractable central fin were added. The SR-71's existence, SR standing for Strategic Reconnaissance, was first announced by President Johnson on July 24, 1964, and the first flight of an SR-71 took place on December 22, 1964. Officially, only 32 Blackbirds were ever built. However, because of the secrecy surrounding the planes, it's safer to say at least 32 were built. These included the A-12, the YF-12, and the SR-71s, and the training variant seen here during the intensive 12-month course. Interestingly, because of the additional drag of the trainer's cockpit above and behind the traditional cockpit, the trainer struggled to break Mach 2 in flight. One other variant was trialled, the D-21 unmanned drone. It would be used in a similar role to the SR-71 in strategic reconnaissance. The unmanned craft was originally designed to be launched from the back of an A-12 Blackbird, subsequently called an M-12. However, after a collision during testing caused the death of one of the test crew, it was modified to be launched from underwing pods on B-52 bombers. Several successful missions were flown during the late 60s, but the project was highly classified and details remain vague. The D-21s were withdrawn from service in 1971 and placed in storage. In 1968, a presidential order required that all molds and tools used to build the SR-71 be destroyed so that the plane could never be built by anyone again. This also meant that spare parts couldn't be made, so if there were any major problems, planes in storage would have to be cannibalized. On its way back to the US from the 1974 Farnborough Air Show, the SR-71 set another record. London to Los Angeles in 3 hours and 48 minutes, including time for in-flight refueling. In comparing local time, it arrived 4 hours before it took off. Though the Blackbirds have officially been withdrawn from service, their cruising speed of over Mach 3 and a service ceiling of over 15 miles has ensured that many of the records they established still stand today. In all the years of the Blackbird program, no SR-71 was ever shot down or hit by enemy fire, and they're known to have outrun over 4,000 missiles. However, they did suffer many losses. In fact, up to 20 were lost, mostly on the ground, during landings and takeoffs. In 1990, with a reputed price tag of over $30,000 per hour, the SR-71 program became too expensive to operate, and their last flight took place on March 6, a blistering California to Washington in 68 minutes. Fittingly, another record. In 1995, the SR-71's talents were needed once again, and the program reactivated. 2 Blackbirds were returned to active duty. Unfortunately, 2 years later, their budgets were again withdrawn, and the aircraft were retired once more in 1997 in favor of satellite reconnaissance. Lockheed's next foray into the stealth technologies was more certainly in the interceptor and fighter bomber realm. Designated the F-117A Nighthawk, it was first conceived in 1978 and finally achieved operational capability in 1983. While this plane is a huge departure from the Blackbird, there's no denying the lineage in their appearance. Its design minimizes both radar and infrared signatures by using a combination of special materials and angles and shielding the jet intakes and outlets. The performance of the Nighthawk is heavily restricted by its stealth design. Its top speed is actually below Mach 1, and the strange shape of the aircraft makes it so aerodynamically unstable that it requires a computer to enable it to fly. There is no doubt these outstanding planes continue to expand the realm of aviation design, but there's still no comparison anywhere to Kelly Johnson's earth-shattering Blackbirds.